వెంకీ పోలా గారు. పెద వెంకటేశ్వర్లు వెంకీ పోలా is an engineering leader and entrepreneur focused on building trustworthy production sale AI agent systems. He is the founder and CTO of One Shot AI, an enterprise platform that blends multi-agent automation with human experts to deliver concise go-to-market outcomes. Over a 16 years career, Venki has shipped large user-facing platforms used by millions. At Salesforce, he served as a founding engineer and architect across multiple product lines, including Salesforce Chatter, Chatterbox, Lightning Bolt, Communities, Experience Cloud, and Commerce Cloud, with a focus on scalable architectures, real-time collaboration, and extensibility. Venki's current interests span multi-agent orchestration frameworks, observability for LLM systems, fine-tuning adapter methods, and voice agents. He emphasizes engineering discipline, clear interfaces, evaluation pipelines, and data feedback loops. So AI features remain reliable and auditable. He also mentors team on lean, high velocity delivery, installing a culture of ownership and product thinking. Venki Garu holds a track record of building platforms that translate advanced AI into measurable business value. And he regularly collaborates with academia and industry to advance practical AI adoption. A hearty welcome, sir. I request you to take over the session.
Thank you. Thank you for the warm introduction. I appreciate it. Hello, everyone. Good evening, all of you. Can you guys all hear me okay? Can you guys hear me okay? Can you please message in the chat if you can hear me? All right. Thank you so much. All right. Can you see my screen as well? Yeah, you can see my screen? Cool. Thank you so much. All right, cool. Good evening, everyone. Myself, Venki. Thanks for the warm introduction. I currently live in San Francisco. I know it's already a long day for you guys. I'll make it very interactive. You can feel free to ask me any questions during the session, and I'm happy to answer anything that you may have. All right, cool. I would love to keep it as much interactive as possible. So feel free to ask any questions. Okay, so we're going to talk about agentic AI systems in the spirit of quantum computing, advanced computing, and application trends. Okay, this is the most happening moment in the software industry right now, in the Silicon Valley and across the world right now. Is how many of you guys heard about SaaS, like software as a service? It has been like ruling the whole industry from last 20 years. How many of you guys heard about SaaS? SaaS? Message me in the chat. Anyone? Okay, so SaaS stands for software as a service. Great. Rekha, you are right. So software as a service. So what does it mean? You can basically go to the software and pay, let's say, a monthly subscription. For example, take Amazon or Netflix for that matter. You are paying monthly subscription, and in return, they're giving a software. You are basically using that software every month, and what it is giving, it's giving you certain output. For example, if you use Netflix, you are actually watching the movies. As for example, you use Amazon, you are getting a delivery service. So that's the service that you are getting by paying monthly 500 rupees or maybe 1000 rupees or whatever it is. Okay. So what's now happening is, this is in last 10 years, last 20 years, SaaS actually ruled the whole ecosystem, which is basically going from on-premise to the public cloud infrastructure, the SaaS. So now what's happening right now, thanks to AI and thanks to advanced cloud computing. So what's happening right now in the industry is SaaS is getting replaced with the agentic systems. By that I mean to say, agentic systems means they actually promise you the outcome, not the output. Like for example, if I use, let's say, payroll software, what it help me is, if it is a SaaS application, I'll use the payroll software to run the payroll for my employees, which is good. But if I use an application like an agentic application for the same payroll software, it can actually not just run the payroll, it can actually go to the market and then find, okay, cool, these many employees are basically maybe underpaid, maybe these many employees and you may have overpaid. So it can come back with the citations and it try to deliver the business outcome. So you can apply the agentic systems across any industry, doesn't matter. So you can basically try to get the overall the business outcome that you wanted to achieve versus the traditional SaaS output kind of approach, right? So right now, if you take a look at the BPO services, like maybe Infosys, or like how Infosys or TCS actually survive in the industry is that they offer the human employees and then say, hey, look, you have a project, and to accomplish this, I need 100 people. So that's how they make the money. So now what the agents are saying is that whatever the human is actually doing, I will actually do the agents, right? So that can be replaced with the agent. I'm going to touch in the later of the session how an AI agent actually perform the task, how an actual human does it. Now let's just go here. So that's a quick overview about what is an agent in general in the industry. So what we're gonna see is, so the way it works is, let me try to minimize this. Perfect. So the high level executive summary. How many of you guys heard about LLMs? LLM, large language models. Have you heard anything about it? Is the first time you are hearing? Message in the chat. Anyone? Okay. How many of you guys actually heard using ChatGPT? Anyone? All right. Cool. So I'm sure you must have heard about ChatGPT. The way it works is, behind the scenes, all these applications use large language models, which is what LLMs. Yeah, so chatbots are there, whether it's a ChatGPT, whether it's a Claude, whether it's a Gemini, Google Gemini, all these kind of chatbots. You ask a question, you get an answer. Unlike traditional way, you are going to Google, you ask a question, you get bunch of blue links, bunch of web links. You are basically going through each of the link and trying to consume the information by yourself. Whereas the chatbots, hey, look, I have a large language model which is trained on the huge volumes of internet data. Now I can actually answer it back to you, whatever the question that you have. So that's what the advanced computing help the large language models, which is basically the frontier models, to actually understand all the context around it. So basically all this, they use giant TPUs, GPUs, and then take the all entire internet data. So they're like 70 billion, 100 billion parameters, 200 billion parameters. So there are so many large language models out there, like GPT 4.5, GPT 5, GPT 3.5. Those are like all the OpenAI large language models. Similarly, there are different family of large language models. Like for example, Claude has its own, Anthropic has its own models, like Claude 2, Claude 3.5, Claude 4.0. And then there is of open source models like Meta, Facebook actually released their own large language models like Llama 2.1, Llama 2.5. So there are so many closed source large language models, and there are so many open source large language models. All they are offering is that any question that you ask, I am better at responding back. And how are they doing? They are doing because they have been went through a huge pre-training, language model pre-training process, using all the advanced cloud computing algorithms out there, and using all the specialized CPU, GPUs, and TPU processors, right? So now what happens is the entire data is now web scraped, like basically it went into stemming and limitation process, and then it basically have like a intent analysis, and finally they train the model with the data. Now the model is ready for getting inference. So when the model is ready for getting inference, it's hosted in the cloud environment. Now you can basically interact with the cloud environment using the applications like ChatGPT or Claude, whatever you want. You can basically interact with them to get the answers, right? So that's how it is. Like you said, like Reka mentioned, chatbots as it's literally exactly LLMs are question answer engines. That's how it started in 2023. ChatGPT launched, and it basically shake the entire internet. And you must be heard about this is the next internet era, right? So what happens is in 2000s, when the internet started, everyone basically turned to the cloud. Now what's happening is everyone is turning to the LLMs, not for an answer, but actually perform a task that I need to do, right? So that's it. So the LLMs actually turn into like question and answers, chatbots. And now the next evolution from LLMs is agentic AI systems. So what agentic AI systems is it's actually promising you a goal-directed autonomy. Like unlike chatbots, where you have a question, with the question you are getting an answer, right? Uh, with the question you are getting an answer, chatbots, whereas autonomous AI agents, what it is doing is I'll actually perform the task for you. So let me give you a classic example. I don't know how many of you guys used within the chat GPT, there is a agent called deep research. I don't know if you heard about it, but take a note of it. So what the deep research agent does is, imagine if I want to book a flight. I want to book a flight from San Francisco to Hyderabad. Let's assume that, okay? And I can just go to Google, or maybe I can go to any chat GPT and then say, give me the airlines going from San Francisco to Hyderabad. So I will get bunch of links, maybe Emirates Airlines, maybe Air India, maybe whatever, right? There's so many airlines out there. So there is one way saying that, hey, look, you want to go. I understand your intention. Your intention is to travel from place San Francisco to place Hyderabad. And these are the airline links. You can go from here. So that's one way. That's basically question and answer. My intention is to actually book the flight. So when I book the flights, my intention is to make sure that I go to a bunch of airlines and I check the fares, the airfares, and I will find the cheaper one, and I'll find the go ahead and then book the flights for me. So if the entire process is the goal is to find the best airlines in the market, find the best fares in the market, and go ahead and book the flights for me. That's my entire goal. But my initial question is, give me the airlines. So what chatbots can help me to do is give me those links, but then you have to go to each of the link and then find the best airlines for you, and then you book the flights. So that is not an agentic system. Where the AI agentic systems is, it will say, hey, I want to find a flight which has a cheaper fare from San Francisco to Hyderabad. And then what the agent system does is it will internally go through each of the link. Instead of giving the link, it will open the browser, it will go ahead and apply the filters, and then find the fare, find the airlines, and then check the fare. And then it does it for all the links, not just for one link. It will go through a bunch of links. If you as a human have to do that across all the airlines, it will take a lot of time. Now what's happening is the agent actually doing on your behalf, going to all the airlines and finding the right flight for you, and then actually making the purchase the ticket. Maybe you can come at the entry level, at the payment level, you can come and do it. But that you get the gist. The end goal here is I need to book a flight with the cheaper flight. And that is what the AI agent is doing. So that's the progression that we are seeing from a large language model, from a pure chatbot question answer to all the way to my goal directed autonomy. So I'm giving the AI agents the full autonomous power, and it uses its all of its tools, which I'm going to touch in the later in the session. It's going to use all of it's all of its tools, and then open the links, and then basically reasoning models you must have heard about DeepSeek, which basically came few months away, few months back, and which actually challenged from China that, hey, look, so OpenAI is actually consuming so many resources to give these kind of answers, but DeepSeek is actually born, let's say maybe in the order of millions of dollars compared to billions of dollars, unlike OpenAI, and they're basically providing the reasoning models. So what these agent systems can also do is it can reason itself, it can make an action on your behalf, and it can basically learn from it, self-learn it. All of this are happening, and that is the future. That's actually the whole industry is moving towards, right? So far so good. Any questions anyone have? Feel free to message in the chat. Before I move on, all good? All right, cool. Awesome. Moving on. So now that you understand what is an agent system, agentic system, how it's actually evolved from a question answer, and how a question answer model is actually built with these advanced algorithms using the cloud computing techniques and GPUs and TPUs through the pre-processing of huge billions of data, right? So now that you have seen, let's just go from here. So you're gonna learn today is how we differentiate from chatbots to agentic system in terms of goals. Every goal that you may give, it's basically goes through a series of planning stage, and you can literally replicate an AI agent compared to, in contrast with completely a human. A human is so good at thinking, right? They can actually plan for the goal, and they can execute, and they can memorize it. They can memorize it, and then they will have a reinforcement learning. That's how the human brains work. And you can mimic exact human brain with the AI agents by using all these tools. Like whether you're going to use tools, whether you're going to use memory, you can use the planning phase, and at end of the day perform the goals. And then you can map the agent capabilities in the advanced computing layers, right? Whether it's orchestration, whether it's a governance, whether it's a data manipulations, whether it's computing, you can basically map out the agents exactly what it does. And you're gonna learn about what is a single agent versus multiple agents. In a nutshell, if you have a job function, let's say for example, you have an HR department, let's say you have like a sales department in the companies, right? There is not a single person who is doing the sales. There is not a single person who is going to look after entire human resources. There is a kind of specialized teams for it. Just like how humans actually started performing the tasks, actually doing a business outcomes with a single person versus having a big teams, you can have the same approach where you can have multi-agent systems to perform the task. And it brings an interesting topic around how one agent can actually interact with the other agent, just like how humans interact with other human. And you can basically mimic the entire that orchestration with multiple agents to perform the task even more higher level, right? So last but not least, you can also, end of the day, you can do whatever the goal you want to do, but if it doesn't give the reliability in terms of the evolutions, the telemetry, the guideline, the guardrails, or maybe the observability, you don't get full conviction on the agents what it is doing. Like for example, I said go ahead and book the flights, and then if the agent says, yeah, I looked into all the flights and here is the flight that you should be using, Venki, and this is it's going to cost you $2,000 from San Francisco to Hyderabad. If it just simply come back with that versus it says, hey, Venki, I found 10 airlines. Oh, I went to this airline and I went to this airline, and this airline is actually not serving from San Francisco to Hyderabad. So I'm not doing that. Oh, I went to the second airline. Oh, this is actually costing you $50,000. Or this airlines is costing you $2,000. Imagine if it can come back with the detailed answer, like step by step. And also it can show you the browser it is loading. Hey, I loaded the browser. I'm actually performing these actions on my face. I will have more confidence on the agents performing the task just like how a human does. And me as an end user get more conviction on the agent because I get a full visibility and transparency what's going on. So I can basically give more and more goals to my agentic systems, right? Cool. So you're gonna learn like what is the real world application trends and what is the real world roadmaps that are coming out of it off the back of the agentic systems. All right, cool. So far so good. Any questions? Quick pulse. You have any questions? All right, cool. Moving on. So let's just go back here from a chat to agency, how it happened. So typical chatbots done the conversations, minimum memory, they don't learn. You ask a question, they get an answer. Most probably they just search it, and maybe you can add something like semantic search, generate an embeddings for the search query, or maybe all the corpus of the data, generate the embeddings, you get a specific information. It's more information retrieval, and there's not much reasoning. It's not ask you, oh yeah, you wanted to search for this. May I know why are you doing that? May I know, is this the context? So just like how an intelligent person, when you ask, when you give them something, they cross question. They basically think, they apply the brain, right? And then they can get back to you with the right answer. So chatbots, very limited reasoning. They don't use any external tools to perform any task, purely information retrieval, static, or maybe a little bit of a conversational. And whereas agents, purpose driven, continuous loop planning, retrieval, they use tools, validations, actions, everything, right? Now the agency loop. So this is how it actually works. If you take any agency action, the way it works is it get a goal, and then it will try to find the steps involved for this goal to perform. And then to perform this task, it might need relevant context, which is basically what grounding means. It can go back to its the data, whatever, whether it's you have enterprise company, you may have internet data, maybe internal data or internal data. It can bring the relevant knowledge using vector embeddings. So basically whatever the goal, and it will generate the embeddings for the given goal, and it will retrieve the right relevant knowledge, and then it will use the right APIs, like right tools. Like for example, it may need to call API call, it may need to call and send an email, it may need to basically write some database queries. Internally, it use these tools to perform the actions. And this is like, it's a relevant context. And this is the planning phase. And this is basically all the tools to perform the actions. Finally, the agents are so good at that, not just perform the task, but also verify the task, verify the outcomes it produced. Let's say if I say I'm supposed to perform the task to find the flights with the cheaper fare, it can actually validate whether this airline makes sense, whether it has good reviews, whether the whether there is any issues with the, let's say the any kind of passengers complained it, and maybe just also check for is it within my budget. So each agent can actually go back to that kind of a critical thinking, just like how an intelligent person, smart person can actually perform the task, and then their manager reviews their output, and the manager gives the feedback for the human, so that the human, basically the actual individual contributor, can actually go back and forth and perform the task. So there is a significant feedback loop cycle to get the right intelligent, to get the right best output possible. Just like how humans perform the task, agents can also do the same way by having the critic agents, which gives the feedback on the original agent so that it can perform the right task in a better fashion, right? And the last but not least, it can give you the right audit logs. Hey, this is what I've done, these are the things I've done, which is all because of the advanced computing, right? It is all because of the inference capabilities. Look at, imagine NVIDIA. I don't know, I'm sure you must have heard about the company NVIDIA, which is selling the GPUs to pretty much every LLM provider. Every AI company in the universe actually needed GPUs, and there is a single vendor, which is possibly NVIDIA, maybe AMD. So what's happening is, you need to know, because those inference, those models, you are able to ask and questions and answers and then perform the tasks. It's basically the huge computing involved underneath, and that is what powered by the TPUs, GPUs, which is powered by the NVIDIA, right? And it is getting all your audit logs, what exactly it has done, right? Cool. So that's the full loop of the agency. Now let's go a little bit of the taxonomy. I'm gonna use a little bit words. Just want to give you clarity on what is this, the glossary of the terms, what exactly it means. So whenever I use tool using agents, it means that initially those are like, tools are like performing actions, just like a human performing action. With the brain they're thinking, and with their hands they're performing the action, and with the body they're performing the action, right? And the brain is what telling what action to perform. So similarly, an agent will have tools to perform the actions. So the tools are nothing but calling certain web services, REST API calls across different systems. That's the tools. Or maybe it can basically perform some database operations, or maybe it can basically open a browser. So all these are like different tools. And you have a critic, which is basically validating the output, and you have a planner, which is basically creating a tasks, creating a deep plan before it actually perform the tasks. And then there is the domain specific copilots. So each domain, whether it's a DevOps, whether it's a HR, whether it's a sales, whether it's a marketing, so each domain specific. So you take any job role in the industry, each job role will have certain job responsibilities, and you can map out all those responsibility across multiple AI agents, and then the whole agents become an agency, and that agency is basically specialized thing on that particular job function, so that it can perform exact tasks what the human is doing on that space, right? So far so good. Quick check, any questions? So far so good before I move on? All right, cool. Moving on. Let's just go to like advanced computing and application trends. So agentic AI is the applied layer. It's basically the application layer for all these advanced computing models, which is basically how models are built, right? Leveraging our foundation pillars. It's actually using the computing and serving. It trends, if you see, look at the smaller, faster models by default with selective escalations for larger ones, right? So there are very like different lengths of LLMs of different sizes. So there are like smaller models which are actually trained on lower volumes of data, maybe 100 millions of parameters versus like billions of parameters, right? There are like different kinds of models which has different kind of parameters that are trained, and obviously as the size of the model, it dictates the pricing, the latency. So some models actually takes longer time to respond back because they had to infer against huge volumes of data versus lower volumes of the data. So everything is a trade-off. You will get the latency, or you can get accuracy, you can get the cost. All these are like different trade-offs, depends on the size of the model. And then the next one is the data and retrieval. So data, and this is interesting, right? If you take a look at Amazon, you search for, let's say, give me the shoes. It'll give you all relevant products from the shoes. So you can just say men's shoes, or women clothes, or whatever it is. It can give you some kind of a regular string keyword matching relevant results, where you can also have something like a RAG, a hybrid search. So RAG stands for retrieval augmented generation. So just like how Google, when you ask a question, it gives you the answer, not just the links, right? Like you must have seen Google answer box. It generates an answer for all the results. So just like how it is doing, you can basically apply the RAG search on all the elements. How the RAG typically works behind the scenes is that you will generate the embeddings for each of the string. So an embedding is basically a numerical value representation for each of the word in English, I mean any, for that matter, any language. So let's say if you want to compare, just like how you can perform arithmetic operations on the numbers, like for example, 10 less than 20. It's common, right? It's because it's a numeric, you can basically compare. Can you compare dog less than cat? You can't compare. Or can you compare a dog is similar to, let's say, a fox, for example, right? Can you compare? You can't compare them because it needs a semantic. You can't programmatically compare because those are English words which are semantic meaning. So what the vector embeddings does is it basically associate a numerical value for each word. Once it converted into a numerical value, you can now compare contrast with the, maybe you can have cosine similarity, or maybe semantic like maybe sin, like sin function, like theta functions, can have like those kind of similarity functions against the vectors and check, oh yeah, these two words look similar, or these two words look further. That's how you can apply a semantic search, even though you search for, let's say, cheaper, and then it can find something like a better prices. So it can compare a cheaper price with a better price, because the meaning for the cheaper and better might be same. That's why it can bring you the results for that. right? That's the kind of trend you can see. And you can also see the orchestration reliability. See, end of the day, for every goal that it is performing, it has to orchestrate all these different agents. Oh yeah, you do this one. Like a planner agent says, I have to do these 10 steps. And then the planner agent has to call an agent 1 to perform a task 1. And it can call an agent 2 to perform task 2. So it can go on back and forth on each of the agent. And then based on the, it requires a lot of orchestration. What's the input required and what's the output it is giving, and how is actually communicating back and forth, how the data is going back and forth. All of that requires a huge amount of orchestration, and that's what being done by the supervisors, which is basically, if you take a look at traditional approaches, which is basically DAGs, like directed acyclic graphs, which is basically more deterministic, and with the AI agents, you can have more non-deterministic to orchestrate, right? Cool. So you can also apply the governance, role-based access protocols, whether it's PII, which is personal information. I don't want to expose my data to public LLMs. And you can also have audit trails, evaluation frameworks, things like that. End of the day, whatever you perform, the task it perform, it needs to have a clear auditability, observability, so that it can give you the good confidence from an end user that I'm actually giving my task to the agents, which is actually not leaking my information, and it's actually using in a more secure manner, and it is giving me full observability what's going on, so that I can rely and trust on these agentic systems, right? So that's it on the application trends. Any questions so far? I would like to keep it more interactive. Any questions so far? It gives me kind of that you guys are actually following the session. Any questions? There? All right, I take it as no questions. I'm assuming you guys understanding everything. Okay, cool. So moving on, reference architectures. So there are single agent systems, like for example, how you hire a human to perform a task. What it happens is user trigger a goal, and it goes through an orchestrator, which is single agent orchestrator, and you can go to planner, and planner basically come back with all the different tasks it needs to perform, and it can basically look back into knowledge base, which is basically the hybrid RAG approach, the hybrid search that I kind of told earlier. It brings all the relevant context and use all the tools to perform the actions. And then finally, like I said, every agent will have a nice critic. And the more you have a critic, the better it can perform the task. So LLMs are instructed to do what it's been asked to do. And then if you ask to critic, it will critic in a nice way. And if you ask to perform a task, it will do that way. The more you critic, the feedback you pass it to the action LLM to perform the step even more further. This whole loop brings you the better output, better outcomes. That's how the single agent systems works, right? Now, if you turn that into multiple agents, which is basically you have a plan agent, which is calling multiple agents, like a tool agent, like critic agent, and you have a decision agent, and you have a retrieval agent. So all these agents working together, and then this plan agent basically orchestrate back and forth, and it can call external systems, or maybe any kind of, it can, all these agents can share the same vector databases. Like I told you last time earlier, each word in the knowledge base can have embeddings generated, and even for the search query can have embeddings generated. And with the embeddings, it can build the vector database, just like how traditional relational databases or maybe NoSQL databases are kind of performed. You can have vector databases to create the embeddings for each of the knowledge base, so that you can retrieve at the more relevancy, right? That's about the multi-agentic systems. Cool. Let's go with the design principles. So when you're building agentic systems, make sure you start with narrow. The more narrowed the task, the better. And it can basically perform the task with more accuracy, so that it can give you right citations. Every task that it performs, if it can give you the citation, that's the best part. That's how you can earn the trust, respect, right? Let's say, how do you know that AI is actually hallucinating versus it's actually the right answer that it's producing? So that's how you can get it. So that's what it is. And then the read only, you don't mutate the data. Make sure you have the agents which are read only, and that's horizontally can be scalable. And there's also a thing called human in the loop. I don't know if you heard about it. So every agent which is basically doing the task, you can actually add a human in at every step. So it can go back and then human can basically review and give any feedback alongside agent performing and critic performing, critic giving the feedback and human reviewing the feedback. And it's a full human in the loop. And you can go back and forth and make sure you have policies which are what tools to use, what role you can perform, access controls or things like that. Make sure you have a success metrics, and that success metrics actually very precision oriented, and then how much time you are saving, how much cost it's producing, how many tests that you call, and what is the output it produced. You can have all of that with the clear success metrics, and ensure that you have a proper transparency. And last but not least, having ethical AI. So ethical AI stands for you are actually performing an AI which is doing ethical tasks, not like unintended harmful tasks that humans like theft or maybe steal or whatever it is. Instead of that, it can basically perform the task which makes the humans better in a more ethical actions. Yeah, those are the few design principles. All right, cool. Moving on, the reliability and evaluation. From the reliability standpoint, you can have evaluation models. Each model is evaluated from their task. I don't know if you heard about unit test, F test, black box testing, white box testing. So just like how you are doing that a traditional software, you can actually do the same thing with the agentic systems. By the time you need to say, you can define the evals, which is called using evaluation frameworks out there in the market, uh, so that your agent is actually performing the task in the production. It can make sure that it can validate whether it's performing the right action or not. You can write the evals. And if a user complain that, oh, it is not working fine, it's not working the way I'm expecting, and you can basically cross-confirm what the evals produced. That's how you make sure that your agentic systems actually performing well in the production systems. And then make sure you have runtime validations, citations, presence, policy guidelines, things like that. So observability we just touched earlier. Make sure that you do the PII masking. Don't share the personally identifiable information to the LLMs. Make sure all the tools that are recalling what's the tracing, what's the producer, what the output it produced. Make sure you kind of save it in somewhere, and you as a developer of the agentic system can actually look into it and then find what's the best way, whether it produces the right output or not. And you can change the prompts accordingly off the back of it, right? Cool. So make sure you have the risk controls, whether it's a knowledge bases, whether it's a privileging permissions. So each agent, when it performed with the given with a lot of tools, each tool basically are permissive, right? Like the more actions that it's performing, the more access it needs. And you have to make sure that instead of giving all mode, I'm sure you must be familiar with this all mode, like God mode in the Linux or maybe Mac OS systems in the terminal, like a sudo, you can apply those sudo commands. That means you can perform anything. So versus you're giving a specific permission for to, or like read only permission, maybe write only permission, or maybe like govern the access to certain applications tools. You can do the same thing with the agentic systems as well. So it is to basically mitigate the risks, what this agent is actually doing beyond what it's supposed to do. So you can control those guardrails, apply those guardrails and role-based access, things like that. Cool. All right, so coming to the application patterns, coming to our original topic, which is advanced computing, how you're using advanced computing techniques into the application trends. And you can see now every job function. I've seen this across the board, whether it's education, ed tech, whether it's a HR compensation, whether it's a customer support, whether it's a DevOps on call, whether it's public sectors, even BPO services, even sales, marketing, development. You take any knowledge worker across any job function, you can apply the agentic systems. And that is the trend that we are seeing. And you can see that the Salesforce launched agentic Agentforce. And you can see even Microsoft mentioned these agents actually performing the code. You can see that a lot of these big companies are now saying, or 60% of their code is actually written by the AI, not the engineer, not the human developer. How is it actually possible? It's actually possible because underneath it's actually built with agents, which is using all these well-trained large language models to reasoning models to kind of perform the right tasks on behalf of the end user's goal, right? Not just the output. So I'm seeing across the board, and it's going to be very exciting moment and also scary moment for the job market out there. Uh, Agents, like for example, you can see everywhere layoffs happening. It's because the agents are actually leveling up. So there is a report that I read, like basically 18 months back. If a human is performing a task for 1 minute, agent can do it. 6 months later, humans performing 5 minutes task, a agent can do in 1 minute, like let's say a few seconds. Now we reached a point if human is actually doing hours of work, humans can do, so agents can do in an order of minutes versus order of hours, right? So it's actually growing exponentially as the models become better and better. The agents can actually get better and better. As the agents get better and better, a lot of applications can build across different job functions, which actually means that every knowledge worker, every consumer can actually rely more workforce automation with the agents, right? That's you are seeing across the board, across all these industries. And the adoption phase, I would say, de-risk it as much as possible. Make sure you have a definite workflow rather than indefinite workflow. That can give you better confidence what tools to call, what models to use, and how much is the context it's actually using. And minimal agent, deploy single agent for narrow tools. That's what I've seen. Like if you take a child and ask them to do 10 things in single goal, they get lost. They do two things, and then by the time they come to the third action, they forget, hey, what I'm doing actually. They forget the first original goal. And the same thing applies for agents as well, because agents are purpose driven. When you have a specific narrowed goal, it's try to perform, and when you need to kind of when you kind of give multiple goals for a single agent, it actually perform, the accuracy gets degraded. So that's the better approach. It's okay to create multiple agents versus single agent so that you get higher accuracy, and you can solve coordination and orchestration using the multi-agent architecture that I kind of mentioned earlier, by using the orchestration and of tools across the tools. Okay. And make sure you have harden it, the agentic systems evals, and make sure you have human in the loop, and make sure you observe the cost. These agentic systems can burn your money, like literally, like they can call the tools, they can call the agents, they can call the LLM calls, and each LLM call involves a certain amount of cost based on input tokens and output tokens, and it'll cost a lot. So you have to monitor the cost, and that is where the observability can actually come in handy. And make sure you have a specialization in formal governance along the way, so you can trust along the sides. So we talked about ethical ways. Make sure you build the agents for ethical actions versus unethical actions, and make sure you perform the task with the citations and observability, and you can basically give full accountability to the agents for what it is doing when you build it right way with all these large language models. Cool. All right, last one, key takeaways. Now you can see agentic AI is one of the most happening application trend that I have seen in the advanced computing. Uh, you can see that's what is happening, agentic AI systems, and you have to build in more better orchestration, better models, better observability, multiple models, multiple tools, observing the cost, things like that. These are all come handy to build a better agentic systems, and which is basically a significant revolution in advanced cloud computing in the application trends, right? So start narrow, make sure you have planner which is grounded, and then make sure human in the loop for critical actions. And last but not least, measure the outcomes, whatever it says that it's trying to produce. Like for example, it gave me the flights to book with the cheaper flights. Did actually the user perform the action, final book the flights? That is the real testimony, right? When the agent performed its task and it produced output and you actually consume it, and you're good, happy with it, the more times the human actually accept the outcomes, the better it is for the agents. That means the agent is actually doing the way what the human is supposed to do, right? That's how the agent's performance is actually measured. And in case if the human is trying to use the outcomes it produced and it didn't meet the goals, it can give the feedback. And that's where the reinforcement learning happens. And that's where these advanced cloud computing algorithms come handy, where the LLMs can actually learn from, you can actually fine tune the models with your own taste and needs and your own style of the work using the fine tuning models, right? Cool. So this is a quick glossary that we touched. Agent, RAG, hybrid retrieval using the keyword and semantic search. DAX, basically directed acyclic graphs, which is deterministic workflows where the agentic systems are can be non-deterministic workflows. And evals to make sure that measure the quality and safety of the agentic functions. RBAC, which is role-based access controls. It goes back to how much the agent is having actions and what are the roles that you're giving. Is it the read-only permission or the write permissions? Is the all mode permissions? So that's what it is. So that's at the high level, the glossary, and that's about the session, and this is about myself. I'm happy to answer any questions. That's pretty much done. Any questions? All good? Okay, over to you. Okay, how do social engineering and phishing scams exploit chatbot weakness, and how can users be protected? Great question, Rekha. Very great question. So how you see this one of the thing which has the governance, the ethical aspect. So what you can do is whenever users are trying to actually you just go there. It's funny enough that you asked this question. So recently I actually locked myself in the home. I lost my key and then I locked the home. So I was actually asking ChatGPT, hey, I would like to unlock my door. I don't have a key. I was kind of curious what it's going to answer. So there are so many several YouTubes, you can actually put a pin and try to put it in the squeeze it out, it open the door. And then when ChatGPT said back, hey, I don't know, I cannot answer this because it is unethical. It get back to me. And I find it quite fascinating because it goes back to if you're exploiting the chatbots, how much the user intention, when you original intention, what you wanted to do, the LLMs can actually, the chatbots, the agents can go through the planning phase and check, hey, is this a right intention? Is it a bad intention? Right? And is the user is actually you're trying to get some knowledge versus you're trying to break the system. Let's say, how can I steal money? Let's say, how can I open the door when there is no lock? Those are like negative intentions, right? I know, even though it's a false do that in my case, I was trying to do my own home. It actually came back saying that, sorry, I cannot answer for this. And the same thing, like there are some people who are saying, how can I commit suicide? I've seen that kind of thing. So chatbots come back saying that, hey, this is not the right way of doing it. So it goes back to how the LLMs, the orchestration, the agent's intention that it is trying to perform. And because of the semantic search, we have talked about hybrid search. It can go back and then look for the intention and the semantic search and come back, okay, there's a good intention, bad intention. Based on that, the further downstream funnel will not be even invoked when the intentions are bad. That's how you can prevent it, right? And you can also provide, for example, any wrong answers, bad answers. You can ask it for, you can ask it to refer the citations. That's when it can look back into the systems and come back, oh yeah, so there is no right citation, maybe the answer is wrong, right? So you can basically apply different techniques to prevent these things happening. But great question, Rekha. Any other questions? Did that answer your question, Rekha? Or you have any follow-up questions? All right, cool. There are 168 members. There's only one person asked the question. I'm assuming everyone is actually listening. Any other questions?
Yeah, Parveena, you
Okay.
can conclude the session.
As we come to the end of the session, I would like to take the opportunity to thank Mr. Venki Polasa on behalf of the Department of Computer Science and the participants of the AICT ATAL Faculty Development Program. We extend our heartfelt gratitude to you for delivering an insightful and enriching session on agentic AI systems moves toward goal-derived autonomy, explained with airline example, ChatGPT versus agent systems, and also about reliability and evaluation models and applications of AI agent system, and also phases of adoption roadmaps. Thank you, sir, for your valuable time and efforts you invested in sharing your knowledge and experiences in advanced academic excellences. Thank you, sir.
Thank you so much, everyone. I wish you best of luck. Thank you so much. Bye bye.